of not winning.
The win began a lasting era of success, which catapulted Williams into Formula One legend. Renowned for their inspired engineering and iron will to win, Frank and Patrick produced a succession of victorious cars.
I think it's unacceptable for a team, if it has the tools, to go to a Grand Prix without turning up there with the intention of finishing first and second. That's what you go there for.
7 Drivers' Championships and 9 Constructors' Championships, making them one of the most successful teams in Formula One history. The modern Williams team are dedicated to keeping the winning tradition alive. One department in particular is working overtime. Jason Somerville is the new head of aerodynamics.
We're continually looking to improve the aerodynamic efficiency of the car. The difference between a fast and a slow car can often be attributed to the aerodynamics.
Every part of an F1 car's bodywork is aerodynamically shaped. A streamlined car cuts through the air better. But F1 aerodynamics also need to produce downforce. Downforce is the effect of air pushing the car onto the track. It's vitally important in Formula One. The cars are so fast that without downforce, they would be virtually undrivable. But if you can get the aerodynamic setup right, the wheels hug the road and the car grips well in the corners, that equals speed on track. The front wing is particularly important. It is essentially the reverse of an aeroplane wing. Instead of giving lift, a Formula One wing forces the car downwards.
The front wing has a big effect on the flow further down the car. And when it's balanced with the rear wing and with the floor of the car, we end up with a package which ultimately will go around corners a lot faster.
At top speed, the car's aerodynamic downforce enables a cornering force of 3.5 times its own weight, which means in theory, an F1 car could drive on a road upside down. Early Wednesday morning. Jason's junior designers have called him to an urgent meeting. They've spent weeks working on an innovative new front wing design, and it's looking good in computer testing.
Well, we've got, as you can see, very significant gain on the prospective F12 front wing. It will give us a greater mass flow into the inboard portion of the end plate, which is something we've been looking to develop all season. Looks to be a really good step for us in that region.
Okay, I think we should take this to the tunnel and get some wind tunnel results.
Jason believes the designers are onto something, but he needs more than computer theory. This is the wind tunnel. The wind tunnel is one of the most prestigious and effective facilities at Williams, allowing the team to get real physical data on aerodynamic performance. It's the envy of many teams on the grid. To save on time and materials, the test model of the car is made to 60% scale. Specialist model makers produce perfect downsized replicas of new aerodynamic parts. As the rolling road powers up and the wind speeds over the model, a guide arm feeds information to Jason and the technicians. They can tell how hard the car is pulling towards the track.
So we've got a good improvement in downforce.
it's going to have?
Well, if we have a good day in the wind tunnel, we typically find of the order of 1/10 of a second of lap time for the average Grand Prix. So that would be a good day for us. So, okay, so we've got improved performance across the range. Okay.
The new front wing is providing improved downforce. Jason now knows he's got something.
Well, the wind tunnel results look very good. From here, I think we're going to go and chat with the chief designer and try and get this wing made.
The team are out for pit stop practice. A pit stop can make or break a race. One slip means several places lost on track. In F1, the crew are selected from amongst the race team mechanics. They are not full-time specialists. They have to keep on top of their skills in between their other work.
On the race team, when they do a pit stop, there's 27 people needed to make a car leave in 3 or 4 seconds. This comes from practice and everyone knowing exactly what they have to do within that pit stop.
To make the stops as fast as possible, 3 mechanics are assigned to each wheel. These 3 and the entire pit crew need to be perfectly choreographed. The race team manager is on the stopwatch and keeping an eye on every individual. A good stop should take under 4 seconds.
Very conscious of the pressure. We've all made the odd mistake. Most of the time we practice so much that it becomes second nature.
The sun goes down at the Williams factory. The night shift keeps pushing towards the deadline. In the Williams boardroom, the search for new revenue hits an important stage. The specialist Williams Hybrid Power Department have developed a Formula One technology which might have commercial potential.
The technology showed real promise in testing in the Formula One car. Then we realized that it has these great applications outside of Formula One.
It's a kinetic energy recovery system. Kinetic Energy Recovery System, or KERS, stores the energy wasted during braking and converts it into drive power. Whilst most F1 teams have a traditional battery, Williams have an alternative mechanical system. When the driver brakes, frictional energy is converted into electricity, which sets a magnetized internal wheel spinning at very high speed. The driver can then press a button and draw the energy from the flywheel to get an extra boost of drive power. The board are impressed with the innovative technology. The flywheel is incredibly efficient.
We're delighted with this flywheel technology. We've all seen the limitations that chemical batteries have, and coming up with this flywheel is great because it shows that there is an alternative that is much more effective, it's smaller, it's lighter, it's cheaper, it has a much lower environmental footprint.
It is extremely exciting doing what we're doing. We're working on a green energy technology.
It's potentially a game changer. Williams believe this is the commercial opportunity they've been looking for. They commit to developing the flywheel.
So we are continuing to invest quite large sums of money in the company because we believe that it's a great technology that is going to have application elsewhere.
Now, with significant investment on the line, Williams need the hybrid technology to sell successfully.
It's important financially for Williams if we've got an additional source of income coming from Williams Hybrid Power.
It's a gamble that could either help the team or prove a costly mistake. Williams F1 driver, Venezuelan Pastor Maldonado. Pastor is a former GP2 champion, a Formula One rookie.
To be a Formula One driver from Williams is a dream, completely a dream for me. Be behind of the steering wheel and to feel the power, to feel all the technology. The feeling is amazing. For sure in this moment I'm living a dream. The feeling with the adrenaline is so high. The adrenaline is taking the control of all your sense. The car feels improving race by race, test by test. You know, Formula One and Williams is always improving.
Pastor Maldonado races alongside F1 veteran Rubens Barrichello. Pastor's rookie seat is a good way for the team to initiate a talented new driver. Williams have assigned him his own Spanish-speaking race engineer, Chevy Pogelar.
After each run, Pastor is giving us the information on what he feels, so we compare what he says with what we see.
They work together closely to optimize the blend between the car and driver. Pastor's feedback to Chevy about the feel of the car is one of the best ways for the team to identify areas for improvement. To help make that happen, the Williams Megafactory has developed one of the most advanced racing simulators in the world.
The simulator we've got here at Williams is one of the best we've got in Formula One. It is definitely much more advanced than any computer game.
All the tracks on the world circuit are laser scanned in 3D. Every detail, down to a minor bump or curve, is fed into the system. Pastor is in for a day of simulator testing. He's trying out street circuits and night events that he's never raced at before.
As a rookie driver, the simulator is really essential to learn everything and to get more confident with the engineers, the way to work, the way to explain what the problems in the car.
If he feels that it's better or worse, and we can see that on the data as well, and from that just take decisions and conclusions just to move forward.
And even in turn 10 on entry, the feeling was okay to carry more minimum speed. But as soon as I touched the throttle, the car was too light. And then...
Try again.
Okay.
The simulator team can even test out new parts. They program in the wind tunnel results from the new front wing design. Instant upgrade in place, Pastor takes the tweaked up car for a spin.
With a new parts, what we do is we test it first here, and if it works, if we see that there is potential, then we continue.